Hello dear students, welcome to the channel of Dr. Gaurav Verma. In this video lecture, we will learn normal distribution in probability. It is a very important continuous normal distribution examination point of view. In a normal distribution, I want to tell you that there are only two parameters. One is a new mean, other is a variance. Now its probability density function. You must know that its probability density function is given by this formula 1 over sigma under root 2 pi e raised to power minus 1 by 2 x minus nu upon sigma whole square. This is a formula for probability density function for normal distribution. Here there are two parameters only, nu and sigma, and x varies from minus infinity to infinity, where nu varies from minus infinity to infinity, and value of sigma is always positive. Generally, we write x as a n nu sigma square. This is a way to write a normal distributed variable. If x is a normally distributed variable, we write n mean nu sigma square variance. If we take substitution z is equal to x minus mu upon sigma, if you put z is equal to x minus mu upon sigma in this relation, so this variable x changes into normal standard variable, changes into standard normal variate with the mean 0 and variance is equal to 1. Generally, we write normal variate like this n01 because in normal variate mean is always 0 and variance is 1. It can be made by putting z is equal to x minus mu upon sigma. Now in this video lecture we have basically discussed the various properties of normal distribution. First one property, it is a continuous probability distribution. As the probability function depends upon two factors only, nu and sigma, so normal distribution is based on two parameters. First property tells us it depends upon two parameters, nu and sigma. Second property tells that the behavior, a symmetrical nature of normal distribution. The normal curve is always a bell-shaped curve like this. It is a symmetrical curve about x is equal to nu line. It is equally distributed on the both sides of nu. So it is called a symmetrical curve. Normal distribution is a symmetrical curve. Property number 3, total area under the normal curve. We always know that total integration of a PDF is equal to 1. Now we will show it. Now we know that the value function for normal distribution is 1 over sigma root 2 pi e raised to power minus 1 by 2 sigma square x minus mu square. It is a definition of fx for normal distribution. Now we will integrate this. In order to simplify, make it constant term, take it out. So we will put this term is equal to z. On rearranging the terms, we get the value of x here. X is equal to nu plus sigma z. From here we get dx is equal to nu dz. As x and y approaches to minus infinity to plus minus infinity, so z will also approaches to minus infinity to infinity, and our integral reduces to this. So this sigma is cancelled with this sigma. So taking the two times of integration, integration becomes 2 times 0 to infinity. Now we have to solve this integral. In order to solve this integral, we will put z square by 2 is equal to y. From here we get z is equal to root 2y. Now we get dz is equal to 1 by root 2y dy by differentiating it. By putting all the values, okay, here it get rationalized, 2 is rationalized, so we get this here. From here root 2 is cancelled with the root 2, we get this one. Now this is a gamma function, e raised to power minus x, x k n minus 1. So I can write it here, n is a 1 by 2, so it is a gamma 1 by 2. And we all know that gamma 1 by 2 is a root pi, so root pi is equal to 1. You also all must know that this integral value is equal to root pi. You can also learn it. Its value is root pi. It is a standard integral. Fourth number property, fx being the probability can never be negative. No portion of the curves lie between x-axis. It means that normal curve always gives the symmetrical behavior above the x-axis. Fifth one, x-axis is the asymptotic to the curve. When we draw the normal distribution, you see previous slide, it is the behavior of the normal curve. So this x-axis treat as an asymptote to the normal curve. Property number 6, movement generating function. It is also very important article. Generally in exam, teacher ask, write or discuss movement generating function of normal distribution. It's a single function. We know definition of ETX into function. Function is 1 by sigma root 2 pi e की power minus x minus nu square upon 2 sigma square. Now we will use substitution. Take z is equal to x minus nu upon sigma. So here we get z square by 2. Okay. Now here x, from here we can rearrange the terms. We can find the value of x is equal to sigma z plus nu. So put this value of x here. So we will get this thing. Now we will collect all the terms. E raised to power tu being a constant term take outside, and e raised to power nu that is added in this by multiplying with the 2 and dividing by 2. So we get this thing. Now we will complete this term. How will you complete square of this term? We will add sigma t square in this it and subtract sigma square t this. So it is a minus b whole square minus sigma square t square. When you solve it, you will get this result. Okay. Now you have to break this part, break this exponential power e की power sigma square t square 2 square and add into outside bracket. So here we get these things. Now this is the only part we remain. Now as the previous part area, we have put z minus alpha sigma t as a new. So we get this thing, take it twice 0 to infinity, and already discussed this value is equal to root pi as in the previous slides. So we will get root pi. So this whole will get value is equal to 1. This on simplification, this is will be 1. So we get this expression from the movement generating function. You all must know that movement generating function of normal distribution e raised to power nu t plus sigma square t square by 2. Further, we have to find movements of normal distribution. Here we will take movement generating function about mean. In order to find about mean, we will take x minus nu. It will be break e की minus nu to etcx. Now this is the moment generating function, and we have already find it in the previous slide. This is formula e की nu t plus sigma square t square by 2. So this will be cancelled with, only we will get this thing. So this is the exponential function, and you can expand it. E raised to power x is 1 plus x square by 2 factorial, x cube by 3 factorial, x n by. And we know that the movements, rth movement about mean mu r, it can be found by taking the coefficient of t r over r factorial. Since there are no odd terms, t cube, t5, t, so there are odd movements will be 0. So all the odd movements of odd order about mean will vanish. So all must know that in the movements in the normal distribution, odd movements are 0, and we have to find even movements. Then we have to take replace r with the 2n. So even movements given by the formula t raised to power 2n over n factorial. So from here you can look at clearly. This is whenever we have to find coefficient of t ki 2n. From here you can find t ki 2n. So sigma power 2n on multiplying 2n factorial above and down, we will get this thing. Okay, so because we have to take the coefficient of t raised to power, we have to take coefficient of t raised to power 2n upon 2n factorial. Okay, so multiply this expression with the 2n factorial downwards and upwards. From taking that, so from here we get this expression for the even movements. Now we will simplify this expression. We will open the 2n factorial, 2n minus 1 up to 1. We will collect odd terms and even terms. From even terms, we will take 2 common from each number. 2 into 1, 2 into 2, 2 into 3, 2 times n minus 1, 2 times n. 2 raised to power n will be common out. It will be 1, 2, 3 n. So this will cancel with this. What is this? This is n factorial. This cancel with this. So these are the expression for the movements of normal distribution. And eighth number property, very important question in examination. You have to prove that in normal distribution, values of mean, median, and mode are coincide. It means that in normal distribution, all three things, mean, median and mode, are same. They have equal value, that is equal to nu. Now first we will find mod, and we know that mod is a value of x for which function has a maximum probability. So how will you find maximum value? If its derivative is 0, then its double derivative will be negative. So in order to calculate this derivative, first of all we will take the log of fx. Okay, since function is e raised power 1 by 2 sigma square x minus nu square, तो power आपकी आगे आ जाएगी, and constant treated as a c. Okay, so when you differentiate log x derivative 1 over fx, then derivative of fx is f dash x, constant term derivative 0. It's differentiating 2 power come outside, ऊपर से कम हो गई, on putting is equal to 0 we get x is equal to nu is your answer. Okay, now we will find its second derivative, again differentiate it twice using the product rule. When you apply the product rule, derivative of x is 1, fx as it is, x minus nu as it is, f dash x. When you put x is equal to nu here, it will be 0, so we will get negative value. So at x is equal to nu, क्योंकि हम as we are doing maximum minima technique, so at fx dash is equal to 0 will give value of x is equal to nu. When we put x is equal to nu, we get double derivative negative. So x is equal to nu is our mod, which is equal to mean. Now we have to also show that median is equal to mean, and we know that a median is a value that divide the data into two equal parts. If this is a median, this will divide the data into two equal parts. In normal distribution, total probability is 1. So this is 1 by 2 part. This is also 1 by 2 part. So minus infinity to m. If we integrate, we will get probability 1 by 2. Using the value of the function normal distributed, we will is equal to say it 1 by 2. Now we will break this integral minus infinity to nu to m. Okay. Now we will solve only this first part. When you solve this first part and putting x minus nu upon sigma is equal to z, so you will get minus infinity to 0 e raised to power minus z square by 2. This is a standard integral as we have discussed in the previous slides. You will get its value is equal to root 2 pi by upon 2 on simplification. So root 2 pi will be cancelled with root 2 pi, so we will get 1 by 2. When we put this value 1 by 2 in the equation number 1, so 1 by 2 is cancelled with a 1 by 2. So this integral is equal to 0. It means if this integral is equal to 0, it means lower limit will must equal to upper limit. If any integral a to b is 0, then we can say that upper limit is equal to lower limit. If both upper and lower limit are same, then integral gives 0 value. So nu is equal to m. What is m? M is our median. So median, we get median is equal to nu. So in both cases, we have find mod, mean, median is equal to nu. Thank you very much.